Hey Isaac, so we back after lunch break, back into the NodePool.
All right, yeah. Back into our test cases. And so I think we've now got these two like kind of mirror image bits of code that this one inserts a node to our node test node pool and puts some extra metadata or some random generated but saved bytes inside. Well, first checks if it's zeroed out properly. Actually, this isn't true in the beginning. We don't zero the memory to start with in the node pool. We should probably do that.
Yeah,
Um, just zero the buffer real quick here. Yeah. UH. And LLVM will vectorize this into like a word by word zeroing, I'm pretty sure.
yeah.
That's pretty easy to optimize. Um,
I'm wondering about
now,
that. Maybe we shouldn't expect that of the interface because if we've got to allocate like a big node pool, then zeroing it can be quite a lot of latency. Uh,
we'll only want some startup there, right? Okay, but then
yeah,
yeah, maybe we shouldn't expect that. You're right.
yeah. So I think that one we can
So,
do maybe in the test and just reach in a little bit and zero it after
yeah,
initialize.
just
Yeah,
for the test.
yeah.
Um,
I'll be back in a second.
so, yeah, so we'll just do mem.set u8 node pool dot buffer 0 just for the test. Well, that comment's not very good, really. Um,
Yeah. We don't need a, or we can just say,
or you just delete it. I don't know.
yeah, till we
We'll see if
figure out
something good to
something.
say.
Yeah. I thought we could add comments like for where we do aggregate, just so that someone reading this can just quickly see straight away, okay, this section is checking that the whole node is zeroed. This node,
Sure,
this
yeah.
is checking that, the page is as we expect. Uh,
0.
yeah.
Is that the right way to say zeroed? I could also just spell out 0.
Yeah. How you had it's good. And then we can do a full stop. The whole node is zeroed. Yep.
All right, cool. So
And
here
then
we've got the 3 steps, or the steps are like acquire, check if it's 0, um, make sure it's not already in our set and put it in our set, and
okay.
then generate a random ID, set the bytes to that ID, and update the entry in our set
Yeah.
to store that ID.
Shall we comment that as well to say why we do that? Uh,
Yeah,
and
sure.
so we say like write deterministic data, write unique data into the node so that we can track if it's ever stomped on. So we can track if,
Doesn't get overwritten.
yeah, cool.
Then here we choose a random node in our node map.
Okay.
Um, verify that it has not been overwritten.
Yeah.
Not been. Or acquired it.
Yeah.
We acquired it, and then we release it.
Yeah. And then I thought we could actually, instead of zeroing nodes, we can rather set them to all ones because that's if we accidentally get a node from outside of the buffer or something like that, then we might just happen to get a page that is zeroed. So if we rather make our
Okay.
default value something unique, and there's also a bug where we have to check that our ID that we generate isn't what our sentinel is.
True.
Yeah.
It wouldn't actually fail our test case. It would just make our test case less strong for that one ID.
Okay.
Um,
Yeah. Oh, well, that's fine then. Yeah.
I think a random U64 is already a low enough chance of that happening that we're fine.
Yeah.
Um,
Yeah. But then, and maybe that's nice because then at the start of the test, we also just choose a random U64 as our sentinel, and then it also shows that we're doing this just for testing the zeroing.
sure, yeah. It's not zero. Then we can't do this trick then, though. That's the only difference. Um,
Okay. Uh, well, we can just do it differently. We can use XOR. Uh, what we want to check
and
then is that.
just
Sorry, Isaac.
yeah, we want to check that every word in the thing is the same.
Yeah.
With XOR, wouldn't you then essentially check that you have an even number of things there? I think that's
Yeah, that's what it will check. Uh,
the simplest is to just do this loop like we have here. Now, LVM may be smart enough to vectorize that anyways.
yeah. Okay.
But our test is not long. It's like 4 things. So I think we
Yeah.
don't have to worry about this. We should just do it.
You mean
Um,
as zeros?
we'll just do sentinels, I think, and just
Yeah.
not worry about some bitwise trick. We should just do the comparison here, make it
Okay.
simpler, and
Okay. Cool.
um,
Cool. Yeah. No, that's good.
the equals random.int use. Man, I get better than numbers. I should just practice typing numbers someday. And so it's like my fingers are still good at typing words, but the numbers have now changed slightly. I put them all on one hand because that seems nicer.
Yeah.
Um, but now they're not in the same row that they used to be in.
Yeah.
Anyhow, Sentinel. Um, then we're not gonna set it yet. All we do is we just choose it now. We don't have to. Oh, we have to do zero them at the start. That's the only like kind of long place.
Yeah.
But that's just gonna be doing this, or no, it's this, isn't it? Yeah.
Yeah.
Did I not fail to copy this? Yeah. It's not just node. It's gonna be node pool.buffer, and then it's gonna be a sentinel instead.
Nice.
And then here we're checking essentially this.
We can actually just call it word.
Even though it's U64?
It's like a U64 word, like it's our word, not a
Sure.
machine word, but yeah.
We also decided we don't support like 32-bit systems, so it is a word for all the
Yeah.
systems we support.
Yeah, exactly. Yeah.
At least so far.
Yeah, definitely. Then the only change would be if 128-bit or 96-bit pointers are introduced, something.
96-bit pointers. I mean, the pointers we have right now are only like 40-some bits, I think, or
Yeah.
like 50, like 47 bits or something like that.
Yeah.
Like processors don't actually use all the bits of the 64 bits they have available.
Yeah. And I think they wouldn't do a 96-bit because it's not a power of two, so it would be
No,
would go.
probably not.
Yeah. Yeah. Okay, then that comment we can just update, verify that the data of this node was released, was never acquired, or
Overwritten.
else. Um,
Has not been overwritten, or since we just need to change this since initialization or release.
Yeah.
Initialization or last release.
We could
We'll
also
just do it like that, I think.
we could also just say that the data of this node, or verify that this node has not been acquired, not already been acquired.
Yeah.
Because if it's acquired by someone else, they're gonna already overwrite the Sentinel.
That makes sense. That's nice and short too.
Yeah.
So verify that the data, or just verify that this node?
Yeah, this node. And then we've got a the before this. Yeah.
Yep. This seems pretty good.
Yeah.
So we do one verification and one mem set. Oh, this needs to be Sentinel. It needs to also use U64 and m.bytes as splice node.
And we must just pass in the type U64 there. Cool. Do you think we can just run it now, just like that?
Yeah, we should be able to. Yeah, this doesn't import anything, so we should just be able to run that. Well, I should use 0.9.0. I guess I should.
Yeah.
Zig test search LSM NodePool undeclared identifier. Oh yeah, look at that. You see how instant that feedback was too? Stage 2 is so fast.
Oh, are you running stage 2 now?
Well, no, I'm not. But this error is implemented in stage 2 purely.
Okay.
How it works now is that the compiler you run is partly stage 2, partly stage 1. Like it does the first 2 phases of analysis in stage 2 purely, and stage 1, the code there just kind of skips that stage and it relies on the stage 2 code to do that.
Okay.
So all this like static analysis that's based on the AST purely happens entirely in stage 2. So this stuff is only implemented in stage 2.
Yeah.
Also, the LLVM backend is now at 60% test passing for stage 2 as of yesterday.
Wow.
So it's getting very close that we're going to be able to self-host.
Yeah, that's fantastic. What is the typical startup time for a Zig binary? What would it be?
That's a good question. You mean like just a Zig binary that's just been built?
Yeah.
It depends on several things. So I think part of that is gonna be like thread local storage initialization. There's just like some miscellaneous overhead that kind of mostly depends on the operating system, really. For the overhead there, there's stuff you have to do like TLS initialization if you're linking libc.
Yeah.
And you're multi-threaded, which we will be if we're linking LLVM.
Yeah.
There's some other overhead. There's a cool blog post on that recently. That was just kind of like on the overhead in a binary, like what's happening in start.zig.
That was Jens Goldberg's post.
Yeah, exactly. Yeah.
I read it. It was fantastic. It was so good. Yeah.
Yeah. So
it's going to be pretty minimal.
Nothing more than C for sure.
Yeah.
Potentially less than C if we've like been able to get rid of some legacy stuff there.
Yeah.
If you're not linking libc and it's a statically linked binary, then it's probably even faster.
Yeah.
Then you don't need to wait for like the dynamic loader to load up your shared libraries.
Yeah.
And so dynamically linked Zig compilers will start faster than dynamically linked ones. For sure. And they'll also be faster too.
Yeah, we don't actually need to link libc, right?
No, we don't.
So we'll on the server side we're
pure Zig code.
Yeah. Okay.
Yeah.
Just out of interest, Isaac, like a quick detour. Can we do like a hello world and just and then run it with time to see like what the
Sure. Oops. Hello. hello W works too.
Yeah.
Zig init exe zig build, or yeah, let's just do zig build. I we should do a release build actually. Well, if you want to like benchmark, you should probably do either release safe or release fast. I guess for our purposes, release safe is good.
Yeah.
And then you can time slash init, or what's it called? Zig out, then hello. Yeah. So it's 0. It's not. Can I get time.v? Is that gonna give me more stuff? Oh, and it sucks because ZSH has their own time thing, and so they won't let you pass arguments to it. You have to do like
Yeah.
/bin/time.
Yeah.
For all the stats.
Wow. That's a really nice.
That's the same thing you'll see in C pretty much.
Yeah.
And we can try the C version too.
So it's less than 10 milliseconds now.
Yeah, you can't measure that stuff accurately in an operating system.
Yeah.
Because it's just scheduled. It's just whatever when your program ends up being scheduled, right?
Yeah.
Main. And that's it.
And return 0, right?
You don't have to.
Oh, okay.
You can if you want to. O2, I guess.
Yeah.
U.C. It's supposed to be O, not 0.
Yeah.
And then slash e.out. And time dash here slash bin slash time dash v dot slash e dot out. It's gonna be the same thing pretty much.
Yeah. It had a bigger resident set size.
1192 versus 304. That's interesting. I bet that's just libc doing libc things.
Yeah.
Yeah, that doesn't really surprise me. It also has fewer page faults.
Yeah.
It has 16 versus 59.
Wow. That's quite something.
These are minor though. But
Okay.
yeah, still.
Yeah.
Yeah, definitely less overhead in the Zig so far.
Yeah. No, nice. That's pretty cool to see.
Right. So back to where we were. We are now going to do Zig test this, and we need to declare. I thought I just did declare Assert. We also need to declare seed, which I think we'll just put as a const here. Const seed equals 42. Set. Yeah, here we are. Set is called pool. Okay, and there's another one here. Pool. Did I miss one?
I think there we go. Yeah. I'm getting a tiny bit of feedback.
All right, I should probably turn you down a little bit. You're up too loud. Testing is new member called I just misspelled allocator. I see.
Yeah.
And we also need to pass in an allocator or the order's wrong here.
Okay,
It needs to be allocator first and node count. What line was that? That was 79. Okay, yep.
Oh, we have to call the function to return
9 allocators.
Yeah.
const does not support field access. Const. Ooh.
I think the random interface changed as well for the same reason as allocate.
Yeah, it is. I just realized that.
Yeah.
I got distracted briefly because Andrew's also made a change on master branch that like fixes the distinction between function body types and function pointer types. So you know how like function pointers are like kind of it's like kind of not very clear that where do we do this? We do this in io.zig or io Linux actually. Was io just io Linux still? Yeah, I think. Anyhow, here this is a function pointer, but it looks like just the same type as this because it's just fn, but not.
Yeah,
On
okay.
master branch, the stage 2 compiler now requires a star const here to make it
Okay.
clear that it's a pointer.
Nice.
And this type, if you didn't have a star comp, this would be a comp time only type. So that's a really nice improvement.
Yeah.
And that's only implemented in the self-hosted compiler so far, but it might get backported to stage 1 just to self-host more easily.
Yeah.
We don't have like special case that in the behavior tests. That the self-hosted compiler is now different from stage 1.
Yeah.
But that's a very nice language improvement.
Definitely.
And so I got distracted thinking it was that first.
Yeah. It also it's like easier to understand. You can see that's a function pointer. Like.
Oh yeah, definitely. It's just so much more clear. I didn't actually fix this, didn't I? We just need to get rid of this. And it also needs to be a function, I believe.
Yeah.
Yeah, what's going on here? NodePool.buffer type. Not support field access. What did I forgot? Oh yeah, I see what it is. I didn't do this. Try. That one allocates on during in it. What to type? This could be a U size, I believe. Assert LM. Oh. Guess that LM didn't really work as I thought it would, or I hoped it would. Or does that just not work on pointers to arrays? That could be. Maybe I want meta.child. I always forget the difference between those two. Let's try it with child real quick.
Yeah.
See, now so it worked for the other one, and so it doesn't work. I think what we need is this, maybe. No? Okay. So this may have failed. I think this just isn't. Yeah, this doesn't handle pointer to arrays nicely. This can give us the array type, and so we could do like child of child. Well, doesn't LM do that though? I'm not very happy with how these things work. So this one does try and handle arrays properly, so we should be using that one. And we still fail on this though, because it says the type is. Oh, I see what I've done. Yeah, I had it right before. I've just made a mistake. I have passed in node instead of a type of node.
Okay.
Yeah. But actually, I just pass a node here, I guess.
Yeah.
And then here, I'll choose type of for this one, I guess.
Yeah.
Now it should be good. Yeah.
Nice.
Our test passed too, by the way.
Nice. Awesome.
So now we just need to make it fuzzy.
Yeah. Fuzz it up.
Yep.
So we're gonna like have some in times that we run the outer loop for.
Yeah. And so do you want to extract these to functions first?
Yeah. Yeah. I think
Oh,
that's
interesting.
great.
These returns compile like this. That's weird. You can return from a test block. crazy. I didn't know that.
Yeah.
That makes sense because you have the tries here too. Cool.
Yeah. But it's kind of not what we intended. We actually wanted to break out of the block and still try and remove
Yeah,
stuff.
I intended to extract these to functions, but I
Oh,
forgot.
okay.
Like, so how test blocks are implemented is they just basically stick the body of the test block in a function and then give you access to that function pointer in the test runner. So the test runner gets like an array of function pointers for all the tests in the compilation, and then these bodies just become test functions.
Okay.
I guess it makes sense that you can return here, but that seems a little bit weird.
Yeah.
All right, so let's just extract those to helper functions. We can have like a test context, I guess, or tester. Actually, we usually just, for Eitzinger, I think we just kind of like made a lowercase namespace, right?
Yeah.
Test Eitzinger, yeah. So
Yeah.
test NodePool. Then here we're gonna grab these things. Whoops. This one's gonna be insert, I guess, or no, acquire.
Yeah. Acquire and remove.
Well, here I think we actually kind of want like a struct type to hold our hash map and test. We kind of want a context type or something. I'm just gonna make
Okay.
this a type for now.
Yeah.
We'll change it in a minute if we want. And I'll call it context, and it will store node pool and the node map. Yeah. And copy, and the RNG we need as well. So like we kind of just need all these things in our test context.
Yeah, it's quite nice if it's all grouped together, and then our fuzzer, the control flow for that is outside.
Yeah, I've got so many syntax errors right now. I need to fix them all.
Yeah.
Want Zig format to work again. Got our stuff there. And I think that seems right. What's the problem here?
Okay, no, I thought it was within it, but it isn't.
Oh, something weird happened. I had a second cursor. I didn't realize that it's a disadvantage to Cocoon sometimes. I've like written over some stuff up there somehow. Now it's all better. Cool.
Git would catch that. Yeah.
Hmm?
Git would catch that.
Oh yeah, for sure.
Yeah, yeah.
Now things make sense again.
Yeah.
Compiler also definitely caught it because or ZLS even just from running the parser caught it.
Yeah.
Okay, so now we're getting there though, slowly.
Should we call it test context?
Context. We can do that,
it's
sure.
just for testing.
And then Sentinel will just kind of like be also, I guess, one of the members of our text context.
Yeah.
Let me write init first. So get the stuff out of my clipboard. And then this is test context. Yeah. It's going to have several fields, PRNG. We're going to have a node pool, or a test pool is what it'll be called. We can just call it node pool though. Test pool. We want to test like different sizes as well. I guess we probably do. So we should make the test context generic over the node size and stuff then.
Yeah. Yeah, because that'll mean that we can test different sizes with relation to different alignments, which will be interesting.
Yeah, that'll be good. Need one more of those. Isn't that right? Oh, I didn't put the FN. Comp time, need node size, and that's gonna be a U size, and then U12, I believe.
Yep, I'll work that out for
Node
us.
size and alignment. Node count is also that can be runtime known though. So we'll just put that in the test init.
Yeah, it is a U12.
Node count can be whatever.
Yeah,
I
that could
guess
be.
actually I think we probably use U32s for that. Because we don't want to store more than that in our actual code.
You
That's
mean
cool. This definition needs to come up.
just in testing, Isaac, or for the main thing?
Well, in our like segmented array right now, we just use U32s everywhere for indexes and whatnot.
Yeah,
And so,
U32 is fine.
cool. Probably want to grab this as well. Testing, see that testing. All right, and this stuff can all be deleted now. I think I've already got that inside our init function. We'll come back and delete this stuff too, I guess.
Yeah.
But not yet. Perhaps we've already grabbed that one. Cool. So now we return a test context from init, and then so we'll have to actually create that type though. So we'll do return. And you can't just defer freeze. These can be air defers now. We need a dnet function. Okay. Probably need to type this because the compiler is kind of dumb sometimes.
We need a self. I think we need self rather, right? Const self equals this.
We need to. I'm just creating it and returning it by value. Then we'll store it. Well, we need selves here. Oh, you're right, because it's generic. Yep. Sorry, that's what you meant.
Yeah.
Self parameter.
Yeah, self parameter. Yeah. Because test context is actually just the namespace function, or it's the constructor function, or not the constructor. It's more like a factory, right?
I don't know. Yeah, it returns a type. I'm not sure we've got a good name for that yet because other languages don't really have that.
Yeah.
It's more of a Zig specific thing.
Yeah.
Yeah.
It's kind of like a generator.
We could just call it like a type function.
Yeah, type function. That's nice and clear.
I think that's a good. It's a very precise name for it. I think.
Yeah.
A function that returns a type. And that's a very easy way to define it.
Yeah.
NodePool equals NodePool. We got node map. Then we're going to have Sentinel nodes. That's what we got then. Node map is going to be an sc.auto-array hash map. testpool.node u64. Cool. dnet will take in. There's nothing we need to take in anything. We need the testing allocator. We can just use that internally to this. That's fine. It's just a test. We just need to take in the test context. You want us to just call it context?
Yeah.
I'll just do like CTX or something, but context is probably good.
Yeah.
Context.nodepool.dnet testing.allocator context.node image. And I need to, before I forget, change these to like here defers. Otherwise, it won't really work.
Mm. Yeah. Yeah, then it won't. It will be pretty interesting what happens.
Yeah, we'll just use after free right away.
Yeah.
Seems good though. All right, I'm happy with that. Into the unit. Now we just need to fix up acquire and release. Then we can write our fuzzer.
Yeah.
Actually, we need to store one more thing here.
By the way, I just realized I learned something for myself like this past week. So with the buffer bleed,
Yeah.
speaking of use after free, with the buffer bleed, any language that has memory safety is still vulnerable to a buffer bleed, because you can have a buffer and then you just write some data in it and you reuse that buffer, write some other data in, and then accidentally return the wrong bounds within the buffer. Then the memory safety of the language won't protect you. So you'll have a buffer bleed and you'll leak like sensitive data. If you're a server, you'll leak it to the whole internet. So it's just as dangerous because you're leaking data, but it doesn't require anything fancy to pull off. Just some unchecked arithmetic, because checked arithmetic helps, but it doesn't prevent it, but it does help.
Yeah.
Yeah. So I actually realized that I used to think that Rust gives 100% memory safety, but it doesn't actually, because this is a form of memory safety violation where you get an underflow. But the borrow checker can't
Yeah, it always
actually.
depends on how you define memory safety. And the Rust people will probably define it to not include that because,
Yeah.
that's there for
Yeah.
their marketing or whatever.
Yeah. But
But yeah.
there is actually no such thing as a memory safe language. Like, yeah.
Yeah, I mean, it all depends how you define memory safety. But yeah, if you include that in your definition, which I think you probably should,
Yeah.
then yeah.
Yeah. The only way to solve it is if your allocator always zeroes your pages before use, and if your allocator never ever returns the same page more than once. And you
Yeah.
also need to
Yeah.
enforce that your program doesn't ever reuse something. It can only have one owner, and that's it, I think.
Yeah. So yeah, that sounds about right. But how enforcing your program never reuses something is also impossible, though, I'm pretty sure.
Yeah.
No way to statically enforce that.
Yeah.
Well, yeah, I mean, it's like, it's not really like a language level reuse. It's more of like a logical semantic reuse, like using the same buffer for two different purposes.
Yeah.
Can just cause a buffer bleed without having like a separate owners inside the language. It's like Rust has
Yeah.
a concept of ownership,
Yeah.
but even that couldn't protect against this because you could still have a buffer that's owned by some object in Rust and that then used for two different purposes. A language can't catch that. It's the semantic thing, not a
Yeah.
yeah.
Exactly. Yeah. Yeah. I just thought it's interesting because I used to always just accept that you get memory safe languages, but actually now I've learned they don't exist. Like it's always going to be a spectrum, like it is always
Yeah.
a spectrum. And when you get into that
Yeah.
thinking, and we realize like things are always a spectrum, then you can start to make trade-offs and decisions instead of thinking it's on or off. Yeah.
Yeah, that's a really good way to think about it. Cool.
Yeah.
Thanks for sharing that.
Yeah. Yeah, I think like my favorite feature of Zig is just the checked arithmetic. Like that by far is.
Yeah, it's just that they have so
Yeah.
many asserts built into the language that we
Ex-
often find ourselves running redundant asserts.
Exactly. Yeah.
Like stuff you would need to assert in C, but you don't need to in Zig.
Yeah.
Um,
And like what we found as well, bytes a slice in the standard lib, because it uses div exact, you cannot get overflow, but you also can't get underflow. It'll protect you from a buffer bleed, which is pretty amazing because
Indeed, yeah.
I think most utilities like that wouldn't think they would let you use a multiple of the type. And if there's a little bit of leftover memory at the end, they wouldn't complain. They would just return less than that.
Yeah. Well, that's like the lowest friction way to do that in C is just a pointer cast essentially.
Yeah.
And then it doesn't matter like if you don't just
Yeah.
divide, which C doesn't have div exact. There's no like built-in thing to assert that division is exact division.
Yeah.
Um,
Yeah.
yeah. It all comes back to checked arithmetic, I think.
Yeah,
Um,
yeah, exactly.
we need to just put context in front of like all these things now. So node
Yeah.
map needs context everywhere in here. Same with NodePool. Oops, not those ones. And that might be it now. Well, we need also context at Sentinel.
Yeah, and context dot node count, node underscore count. That because that one's runtime known.
Oh yeah, we need to store that, don't we?
Mm.
Okay. Put that first. Node count equals, oh, it equals node count, then we put the type above. U32, that's what I used, which I think is fine.
Oh.
I think it's fine. Alright, and then, yep. These need to return a possible error, because we can have our tests fail.
Yeah.
And we can have allocation failure as well.
Okay.
In which case we just end the test. We don't need to do anything special there. Right, unique data. That's all. I don't see any more things we're missing. Oh, random. This is now context.prng.random.
Can we not just? Oh, we have to keep PRNG around for deinitting here.
Yeah, that actually holds the actual implementation. Random's just a fat pointer.
Yeah. And could
exactly
we
100 columns.
cool. Isaac, could we cache the value of random and then use it everywhere? Would that be still correct to cache that fat pointer?
Yes, we could, but PRNG needs to be alive still throughout the whole.
Yeah.
It still needs to be stored somewhere in memory.
Yeah, exactly.
And so we could pass the PRNG into this test context. We could have like we could just pass in a random pointer here into a net and let the outer scope deal with that. Maybe that's better, actually. I think that is better.
It is better.
Let me just store a random in here.
Yeah, good idea.
So let's pass in
yeah, just like that.
random.
Because that's where we will use it. The outer scope is going to be doing a lot of random decisions as well.
Yep, and so we'll just do that, and this will go out back up to the outer scope. Leave it there for now. And then here we're just going to store rand.random and just call it random. Well, that was kind of redundant. Okay. I think that does it. Just a PRNG down there now. Okay. Now we've got anything else left to do here. We've got context.node, sentinel, node map. That all looks good to me.
Yeah.
And release still needs an argument.
It's going to be self, right?
Oh, yeah. There we go. Release. Okay, I think that's all. Oh, this one needs to have this. But then I think we're good now.
Okay.
Now we've got our test context helper. Now we need to just kind of like write a fuzzer, which I guess we could just do right in this test block. So our context equals test context.init, or text context, node size,
Node
and
alignment.
node alignment.init.
and pass in an
And then it will take
allocator.
in the random. I guess we can probably just use the same random. And then the node count. Okay, and then defer the DNet.
Don't we pass in an allocator as well to test context?
We don't need to. I just kind of use the testing allocator inside here.
Oh, of
Since we're
course.
using it only in testing,
Yeah, yeah,
I just use testing the allocator directly, which I could get rid
yeah.
of the STD here actually.
Yep.
Um,
Oh, that's a cool idea.
cool. So now we need to kind of do our buzzing, I guess.
Shall we try
So,
run it just to see what happens?
oh yeah, just see if it compiles.
Yeah.
Probably won't. Yeah, unclear identifier node count. So 82. Yeah. Yep.
In
Oh,
the
well,
function, yeah.
yep. That explains that.
We need missing
Yeah.
a try. Yeah.
Um,
Oh, that's going to be a self actually. Under that DNet.
oh, that's what it is.
Yeah. Okay.
Passes.
Great.
We haven't tried release acquire yet though.
Hmm.
We can try just at context acquire and then at context.release just to make sure that compiles and runs too.
Yeah.
Oh yeah, we can use try here, don't we?
Yeah. Hey.
Yep.
Nice.
I think we're good to go.
Yeah.
Time to fuzz.
Yep. Shall we set like ticks, have like const ticks equals something, or we don't even need
Yeah,
to
sure.
declare it as a variable. We can just start the loop and say I, and while I is less than 1,000 or whatever. Unless you want to define ticks some way.
I think that's fine. And then in here, well, we're just gonna do like a randomly acquire and randomly release.
Yep. Yeah.
And we need to, and we also handle like going out of bounds too. So maybe like for the first loop, we should have like a 2/3 chance of acquiring and like a 1/3 chance of releasing, and then do another loop where we release more often than we acquire.
Yeah.
I don't know,
Yeah.
something like that.
Yep. That's cool. So that we
Cool.
growing it and then declining. That's a nice,
Yeah.
really nice idea to have too.
Cool. So how do we do that? I think we want to just do PRNG. Well, random will have us have all those interface functions. I just want to choose like which thing we want here. Is there like a, if we just do uint at most 100 and then check or compare that to,
We
or we
have
can even
some.
just do like 1 to 3, and for if
Do
it's
we?
1 to 2 then we acquire. If it's 3 then
Yeah.
yeah. So let's switch random.uint at most.
Bias.
So it's gonna be 0, 1, or 2 actually.
Hmm.
It's gonna just be like a 32. Doesn't matter.
Yeah.
At most 2. And then we'll switch exhaustively on that. Actually, we could use like a U2. Is that what it is?
Yep.
U1 will just have 0 and 1, and then U2 will have 0, 1, 2, 1, 2, 3, and 4.
Yeah.
And we might as well just make this 3. And we can just use int U2 perhaps.
Yeah.
And then we'll have 75% instead of 2/3, but I think that's fine.
Yeah.
Just because it's more convenient.
We should use int biased, I think.
Oh, I used to use normal int somewhere, but I don't remember where. I think the Sentinel.
Yeah. That's okay.
That's the wrong thing.
Yeah.
Um,
Well, actually, yeah, we should use it everywhere in biased,
int
if
is
there is such
evenly
a thing.
distributed. Yeah, I think this one actually might not have a biased version
Yeah. It takes bytes.
because
Uh, yeah.
it takes bytes. It just takes the bytes and gives you that.
Mm.
The reason we have the biased versions is because they're limited in the range. They're not like
Okay.
byte aligned,
Okay.
I believe.
Yeah. That makes sense. Cool.
Because here we can't just take the bytes and use them. We have to like clamp it to this bound.
Mm.
Um, this starts by just taking int. I think yeah, this is the unbiased version. It starts with just an int, but then it needs to clamp it to the bound, and so it kind of does this iterative, potentially exponential thing.
Yeah.
Okay, so it's only just int then. And here we have 0, 1, and 2. We'll just try context dot, oh, I've got missing parentheses there. Acquire. And otherwise, if it's 3, then we're going to try text.release. I think I'm happy with that. And then for the second loop, we'll then release more than we acquire. We'll do just 0 is acquire, and then 1, 3 is release.
Yeah.
How's
There's
that
just
look?
one. It's good. There's one little problem where we not. So if
Yeah.
we decide to acquire, then we only acquire. We don't release also. So we need to make those two decisions different.
Oh,
Uh,
okay.
yeah, we kind of need two random ints for each.
Well, we do that like once per loop, though. Like we do this every loop, and so every loop will either acquire or release. And so we will both acquire and release in this
Yeah,
during
okay.
this phase.
Okay.
So there is a bug though. We don't reset I,
Yeah.
and so we should make these
Yeah, great.
like
That's not
this,
a
and
sweated
grab
int.
I, put it in here.
That's nice.
Get rid of those two.
Okay, cool. So basically there's a 60% chance, 66% chance that it will acquire
Well,
on
it's
the
actually
on the tick.
75 currently.
Okay.
We've got, but yeah, I think this works for U2s.
Yeah.
Um,
Maybe we should make it a little bit more like just over
it
50.
does,
Like,
yeah. Sorry.
sorry, Isaac, maybe we can do it like, we can't do, because we just want to bias it slightly towards acquiring so that we're still doing some
Okay.
releases.
We can do that more slightly if you like. We'll use just
Yeah,
uint at most or
bias.
uint less than biased. Just use U32 and then just use 100 because that's easy for us to reason about.
Yeah,
And
yeah,
then we'll go for 0 to, what do you want, like 55?
yeah,
And then 56 to 99. Even like
yeah.
just we can make it 62. I think 10% more is
Is
good.
better. Yeah, I was thinking
Like
60,
59.
60 as well is good.
That's 60% now because it's
Yeah,
inclusive for these ranges.
okay,
And so,
cool.
and then do we want to do the opposite here then?
Yeah,
Probably.
we can actually then just keep everything exactly the same and just put release in the top branch and acquire in the bottom.
It seems like less readable than changing the numbers, but maybe I'm wrong.
Okay,
Uh, I'd rather change this to 40 or 39. Make this to be 40. I think that's like easier to overlook that the names change because they're,
okay,
I'm not sure.
cool.
Yeah.
Okay.
So we run it.
Yeah, let's go for it.
All possibilities. Oh yeah. Else unreachable. Because
A U32 is
the
got.
full U32 range is not covered by these numbers, but the random interfaces are guaranteed to return something in that range.
Man,
Pass.
okay, cool. That is such a cool thing on that exhaustive switch that it actually checks the type range, not, well, obviously it has to check that, but yeah,
Yeah.
that you can do this is very cool. Great. And then what we should do at the end of the loop is we should assert that the node buffer is now back to our sentinel. And then, well, we just want to,
we have to release
we need to release everything, yeah. So just do a loop while there's stuff release.
Yeah. While context, we can release them in a random order too. So while context dot node map, should we just have like a context dot release all function and like put that inside the abstraction?
And keep all the testing in there. Yeah. That's very nice.
So this is gonna be just while context dot node map dot count greater than 0 context or try. Cool. And then we can actually put the test in here to ensure that the whole buffer is zeroed.
Yeah.
So actually, after every release, we will, or even like in DNet, should we just, no, DNet, that's not the right place to test stuff. You shouldn't test things in DNet.
No.
But we can.
I think in release all, it's a good check to have again.
Yeah, I think so too. What have I done? Okay. There we go. And then this needs to be for the whole buffer instead of just node context at node pool buffer. That we'll be verifying that nothing in the entire buffer has been acquired. I think you need to ban someone from the Twitch chat.
Yeah, I see that. So this is when we changed our follower chat settings.
Oh, is that why we did that? Did we get spam before?
No, well, it's the default setting that we had so that people have to have been on your stream just 10 minutes at least in the past, or they're like, I think they have to be a follower. No, they just have to be on your stream. But what we could do is say followers can chat.
Sure, that sounds fine. Does that actually filter out the bots though, or the bots just follow us?
Well, if they like, so this was just a viewer, not a follower. I'm trying to figure out how to moderate from within Twitch Studio, but I don't see it. So I'll go.
Yeah, I'm not very useful from IRC. I can try and ban them, but I don't think I've got any permissions.
I'll go clean it up later. And so you think let's set our setting to chat from followers only?
Yeah, as long as we don't have that like 10-minute wait period, then it's probably fine.
Yeah.
Yeah. We can run this now. Still passes, so we should be good then.
Yeah. Then Isaac, I thought we could just assert that maybe in test context we want to keep a counter of how many acquires we had and how many releases we had. Count both of them, And then at the end, we want to assert that they're equal and assert that they're greater than 0. Because we want to actually be sure that we did do something, that some work was done.
Yep.
Yeah, that's nice.
U64 or something.
Yeah.
So we never run out of space.
Yep. Releases. And we can set them to 0. Remember, like that one test we wrote.
And then here, only if we actually do the acquire.
Yeah.
Sorry?
Remember that one test we wrote, and actually it wasn't testing what we thought it was testing. And we needed to actually like test the test.
Yeah.
Yeah.
Indeed. I'll just put this at the end of the function, I think.
Yeah.
We don't want to do it before that early return.
No.
And then in the end, or at least all, we do the assert, I guess.
Yeah.
Should we print these as well?
Yeah.
I want to put a new line here too, because just to defeat the test formatting.
Yeah.
And then wrap this, I guess, or do it like this, maybe? Yeah, it looks kind of ugly. I'll do it like this.
That's nice. And then we should just add a test that to expect that they're equal and greater than 0.
Yep. They were 854 this time.
Nice.
For reference.
Nice.
We're testing something.
Yeah.
Try testing.expect.
Context acquires greater than 0.
Yeah.
And then we can do expect equal, that they're equal to each other.
We don't really have, I'm not going to expect equal here because we don't have like a constant to put in the first one. You know?
Yeah, cool.
So I think it's just we want to assert that these two things are equal.
Yeah.
Not that we're asserting that one of them is equal to, ooh, that's not right.
Good catch, yeah.
Releases.
Yeah. Nice.
Cool. Our siege is 42. So we should get the same thing every time. Yep.
Yeah. Okay, nice. Are we going to put this now, map it out for a few more types?
Oh, you mean for a few different more comp time parameters here? Yeah, we should do that.
Yeah.
So maybe this should go, like this part should go into another helper that we then pass. We then call like a comp time loop.
Yeah.
So yeah, we could have like a test context dot, or we should kind of just need like a test function.
We could actually put that all within test context as well, and just say like test context text context run, and then it runs it. So you do like you init it, you run it, and you de-init it, and then you do another loop.
Oh sure, that makes sense.
Yeah.
Run. That'll be void, and then stuff will go into run. Oops. Stop being fancy. Right. Context.run. Yeah, we didn't use the random in here. We need to use test
Yeah.
next to random now.
Cool.
Yeah. Okay. Should now compile, I believe. Hope. Yep.
Yeah. Awesome.
Cool. Now we need just do this in a like a comp time while loop, I guess. Just do these things. So what are we gonna like leap over? What do we want to try? Like for node size, it has to be a power of 2.
Yeah.
Alignment also has to be a power of 2, I believe.
Yeah.
Or we should probably assert that alignment's a power of 2. Oh, we do. Good.
Yeah. We can do like node size greater than alignment and node size equal to alignment. Those two would be good.
Yeah, we could just we could do it kind of two ways. We could either have like a static list of pairs we want to test and just kind of make that list manually.
Yeah.
Does that sound good? Or should we like kind of try and do some for loops?
Yeah, we could, you want to just like brute force it.
I was just thinking we can kind of just do like a inline
let's try that.
or and then just kind of like have a anonymous list of sizes and alignments.
Okay.
I don't know. We can also just do like a nested inline while kind of thing. That's probably the better way to do this. Var. We also want to ensure that we test sometimes when they're equal, which becomes a little bit trickier to do with that strategy.
Yeah, we could. You know what we could do is have a while loop where we just copy these 3 lines twice, and the one will test where they equal, the one will test where it's just double. Because I think if we do equal and double, that's fine. We don't need to do like quadruple. I don't know if that changes anything.
So we'll just go based off node size then.
And then we
start this off at like 4. I don't know. That seems ridiculously small.
Yeah.
Or actually, we can just call this I then for our loop variable, and then derive node size and alignment from that. But I should always be a power of 2.
Maybe node count is also something we want to do exhaustively across all kinds of node counts, from 1 to 7, or you know what I mean.
Okay, yeah. Node counts runtime node though. That can happen like inside the inner loop.
Yeah.
We can do quite a few of those. We can do like up to 100 or something. I don't know.
Yeah.
So I'm just gonna do like it should be a comp time var. Var I equals. We're gonna start off at just 2, I think. It's a power of 2. This will be like node size, or this will be alignment to. Well, alignment could be. We should start at 1 though. I feel like. I think it works for 1.
Yeah. Maybe, Isaac, we must just do node size and alignment. We must hard code what we want, because there's actually only a few of them. It's 1, 2, 4, 8, 16. And then we're going to do node size, related to that. It's a small list of tuples.
Okay. Okay. So I think that works too.
Okay.
I think we should just do something like this then, where we kind of do inline well.
Yeah.
Or inline for over these things.
Yeah. That's very nice.
Maybe we just need like a little struct type that holds these 2 things. Just make it readable. Const equals struct.
Let's just call it tuple. Then we don't have to write parameters out with a p. Yeah, tuple.
Node size usize node alignment U12. And then we're going to have a list of these things. Tuple. Actually, you might be able to, like, I think it's the better way to do it is do it like this. Tuple node size equals, I don't know, we can start this off at like 4 and node. This is going to be nice just like this, I think you're right.
Yeah.
Also 4.
Yeah. And then 4.
And then when we finish the rest of it, maybe first,
Okay.
tuple,
Okay.
or just like get at least properly formatted.
Yeah.
And we can add more of those things.
Good.
And then we're gonna have here like const context equals this type.
Passing in tuple.node size, tuple.node alignment.
Yep. Tuple.node alignment. And then node count's going to be then random, or going to be another inner loop. So like var I usize equals 1. It's a U32 actually.
Yeah.
For use for count. While
I thought
than.
what would be interesting is to set the limit to be node size times node alignment times 2, so that we're getting to products of each other if they interact.
No, it's not tuple. Times. Then we're just going to increment by 1, I assume.
Yeah.
So we get all the odd sizes between there as well.
Yeah. We could.
Okay.
Okay, yeah, we do have to use defer. Maybe we should add a new line after dinit, and then we do context defer and then try run. Yeah. I've been thinking like for Tiger style, we should always say wherever we allocate resources and dinit, we should always group them with new lines so you can see it makes it much easier to spot a missing dinit. Oh.
Yeah.
Or I guess it makes it easier to see that the dinit is accounted for. Yeah.
For sure.
Yeah.
Cool. I think this runs now. Should we just try this real quick?
Yeah.
Unused local constant. Isn't that nice?
Yeah, awesome.
U64 found a line for U64. Oh, yeah. So we can't do our... That makes sense.
Mm.
So here, we're using U64 words, but if your buffer ends up being a line 4 instead of a line 8 or greater, then that doesn't work.
Yeah. Nice.
It's pretty neat having alignment in the type system.
Yeah. I put it on Twitter like to say that we're going live today, and I was almost going to put something in about check out some cool alignment stuff in the type system, because I figured like what we were doing yesterday, if the NodePool, we'll talk about it today as well. You know?
Yeah. So what's the best way to solve that? We can just like get rid of the U64 thing and just use U32s.
Yeah, if we use U32s, then there's like very roughly a 50% chance that, well, yeah, to have a 50% chance of collision, we'll only need about 65,000 runs, and then something will collide with the Sentinel. So
that's not great.
Yeah, U64 is good, and we can just start our test from 8.
Okay. We're just 8 alignment, I guess. We don't need to use 8 size actually.
Yeah.
Wow, that took too long. This should already run, I think. Unreachable code. Oh, node size mod alignment equals 0. Is that actually required? Do we allow it over a line? Because this actually won't be true. Oh, it does have to be true, yeah.
Yeah.
Otherwise, we introduce padding. So we start at 8 and 8, and this should now actually compile.
Yeah.
Look at this content asserts just like coming in handy.
Yeah.
So now we've passed all. You should probably get rid of this printing now, I guess.
Yeah.
Or silence it at least. I'll just like comment it here. Let's like do like an if log thing like we did before.
Yeah. If context.log.
Or I think we just use a comp time const that is just. This is what we did on the Eitzinger stuff. I thought it was pretty nice.
Yeah.
Like you're never gonna really need to set this at runtime.
Of course. Okay. Yeah, that's
so
much
just
better.
kind of stick this like here somewhere.
Yeah.
And so you can easily toggle it while you're debugging stuff, but you don't ever commit it. Well, that's the wrong thing. I would just leak my local IP address to everybody.
Oops. Okay, 116.47. Shall I cut this out from the stream?
I don't think it matters.
Okay.
Do you think it matters?
Yeah.
It's pretty easy to find my IP. Actually, I'm also using a VPN, so they wouldn't even show my local IP address.
Okay, so it's not. Are you happy? It's not a problem.
I don't think it's a problem.
Okay.
I'm not worried about my security is so bad that someone can like just hack my computer remotely.
Okay. Cool.
I just forgot to type the Z, I guess, and just did I autocomplete.
Yeah. Yeah. I don't think it's a problem.
Yeah. Especially since it's not even my actual IP address. It's like the whatever the VPN provider's given me today.
Yeah. Nice. We can do 8 and then 816. Oh, we can't do that. Okay, so we'll have to do.
16 here. Well.
Yeah.
16
and 8.
16, 16.
Yeah.
And then like 32. We also do 32 and 8.
Yeah.
What else do you want to do? 16.
32 and 16.
Yeah, 64. 16. Stuff like that.
Yeah.
Takes a bit longer to run now.
Yeah.
Because we're doing here node size times alignment. We can make the step here bigger, maybe. I don't know. We also make the step there random. Like not always test every I, but like increment I by a random number, like between 1 and 5. Maybe that's not a good idea. I don't know.
Yeah. We can drop the times 2. That should be okay.
That should already cut the runtime down by a good bit.
Yeah.
We also like try dash oh. It makes it faster. Yeah, it's just gonna take longer to compile then. That's kind of the trade-off during testing.
Yeah.
So if you build an optimized test field, then it just takes longer to compile.
Yeah. We could drop some of the types, like we. Maybe.
Well, it's this one that's really taking the really long time. So it's the 64 and the 16.
Yeah.
We could just cut this down to 32.
Yeah.
That should already cut it down by a good bit. I don't need release safe. Hold up. That's not bad now.
Yeah.
Or not too bad at least. You don't want to set this by something other than 1. You want to test every single one every time.
We could do. We just need to get onto power of 2s also.
Yeah, we do need to test all the power of 2s. We don't want to just like skip them by accident.
Yeah. We can also reduce the number of runs then to not be, at the moment it's like 64. You see, even if we set it to 100, 32 times 16 is like in the same order, right? Or it's a little bit bigger. It's
Yeah, okay,
512.
so one thing we could do here is that we, instead of adding 1, we like, you'd start this at 16 and like add 16. I don't know, or start this at 8 and add 8. That would already cut it down by like a power or a factor of 8.
Yeah.
What do you think of
That,
that?
it's a good idea. The only thing is we do need to start from 1 so that we have got test cases where we only have one node in the, because that's pretty interesting boundary condition, you know, just having
Okay,
one.
yeah. Sure, yeah. We could special
So
case that test case though. Because that's
yeah,
already like that's a good chunk faster, like with that. Or
okay.
maybe it isn't.
Let's leave it at 1 and then just drop one of the other types. So we've got 3 of 8. So we can drop the 32 and 8.
That's
Yeah,
probably good then.
yeah,
With the cache, then yeah, that's see that's something that made a whole bunch of difference.
yeah.
Um,
Oh,
I think
otherwise,
that's
yeah. Hmm. Maybe we don't need so many runs. We can have a smaller node count. Maybe it doesn't need to be a function of node size and alignment.
I'm not sure it needs to be. Yeah, I think it's just oh yeah. What should we just like cap it at 4096? I mean, what is it right now? It's going to be 32 times 6. It's not even that many right now,
It's
really. It's like
512. Yeah. So we could go up to like
yeah.
64, cap it at 64.
Okay. Um, that's gonna be really fast then, I think. Let's not do that again.
Okay, cool.
That's
And
really fast, yeah.
Isaac, I've had an idea
8.
as well. I think we can look at in context run. If we go up top to context run, you see there we've actually got some numbers.
We're just kind of hard coded 1,000 and
Yeah,
1,000. Those don't need to be hard coded really.
yeah. We should
Um,
maybe say context dot node count times 2.
something like that, yeah. That sounds good. Otherwise, it's just gonna run yeah.
Yeah,
Um, I kind of want to do times 4 just to like make sure it tests out the boundary a lot.
yeah. That's
Oops.
good idea. That's much better.
That's gonna be way better though.
Yeah,
Cool. Maybe you bring back one of those cases then.
yeah.
Maybe it's taking too long to compile, but maybe that's just my imagination speaking. Okay, because we were at 128 now. If we take that down to 64, yeah. What's the? Can I get a test command? I want to like actually just run the test command instead of compiling it too. Um, test no exit. Tell me the command. No, it doesn't. That's annoying. Um, the command is actually like somewhere in Zig cache to run it, and so
Yeah.
anyhow, this binary path the test command args.
But I think we're good though, like on the test time now.
I think we are, yeah. I think that's good. Are you happy with how much we're testing still?
Yeah. And you? Do
I
you
think
want to
so.
do you want to do more of multiple of a node alignment, like 128 over 8, or 64 over 8 and 128 over 16? Because
Sorry,
that
I'm not
way,
following what you mean. You mean like node
um,
size 64, alignment 8?
yeah, and then node size 128 and alignment 16. Because that way we're kind of checking a multiple of the node alignment in the size. It, it's node alignment times node alignment, just to see if that surfaces anything interesting.
Sure. It's gonna take a bit longer to run though, I think. We'll see.
Yeah.
Actually, not too bad. Cool.
Yeah.
All right, let's go with that then, I guess.
Cool. Shall we try and break some stuff and see if our test catches anything?
Yeah, just to see if it just worked. If it
Yeah.
works, yeah, sure. Let's just like do an off by one somewhere. I think
Okay.
that'd be the hardest thing to catch.
Yeah.
What if we just like unset the wrong bit here?
Cool.
Probably gonna go out of bounds though then, but we'll just let it do that if it wants. We might just get a crash because it goes out of bounds.
Yeah.
Um, yeah, we got a crash because it went out of bounds. So let's like
We can say if node index is greater than 0, then -1.
yeah. Here's an off by one that won't crash us through that.
Yeah.
Man, my keyboard just really wants to type IP adder for some reason. Yeah, so we hit our assert in the test itself, not even in the test case, in the code itself, not even in the test case.
Okay,
We do
cool.
this assert here.
Yeah.
If we got rid of that assert, I think we'd also hit the test case failure though.
Mm.
Yep. We then hit our sentinel thing.
Oh. Cool.
Cool. That seems like it's a really solid test then. We had to like we'd have to delete 2 different checks to be able to
Yeah.
do something to make an off by one fail us.
Yeah. Yeah. Awesome.
Cool. I wonder if we want to get rid of this test then in production, or this assert then in production, for performance.
I don't think so, because like we'll use this for segmented array, and we're just looking up the bit if it's checked, and it gives us like defense in depth. So it means that if our other assert fails, we've still got this one to back us up.
Yeah, makes sense.
Yeah. And this is just kind of like the buffer management. So the data plane, it isn't really like data plane, because we just have bigger buffers, and then it's
Yep.
amortized. You're doing all the CPU work on the size of the buffer, whereas this structure is just the actual buffer pointers. So
Sure, yeah. Cool. So shall we do a commit then and commit this
yeah,
stuff?
yeah,
I'm pretty happy
awesome.
with how this test works.
Yeah, me too. What's our ratio of actual implementation lines to test lines?
Yeah, good question. So here we've got essentially, well, it's not telling me how many lines of, oh, I can do that. Let's see. That's gonna give us, that's 60 lines of implementation, counting white space and everything.
Yeah,
I'm assuming our style is pretty much the same for the test.
yeah.
One. Oh, I see what I'm doing. Yeah. Test code is starting here. Just do it like this. The test has got 159 lines, so it's about like roughly a little over 2 to 1
Yeah.
test to implementation.
Yeah. Cool.
So we actually are testing a lot more code there, because we also test the dynamic bit set code now, essentially.
Yeah.
Like the standard library's bit set is also getting tested through this.
Yeah.
Which is good.
Yeah. Yeah, that is good.
So we don't trust anybody, not even ourselves.
No. Yeah, exactly. Yeah. Yeah. Yeah, it's not bad. Like 200 lines of code for pool allocation.
Yeah. And we can use the same tests for the block free setup too.
Yeah.
Essentially the same tests.
Yeah.
Or like a similar strategy at least. We can take inspiration from that for those.
Yeah.
We won't have we can't do the sentinels as much, but we can like kind of do the same thing with we can kind of like treat them as pointers and have like an array where we like write a single number into, indexed by the block index. Something like that to simulate the same kind of check you can do with the sentinels here.
Yeah. Did you see the block free set tests that DJ did?
Oh no, I didn't yet.
Okay.
Probably why I'm
Cool.
talking about this.
No. But I mean, we should add this there too. In addition, like it's nice. Just add more and more. It's also good that we keep the tests lightweight. So this fuzz test is very powerful, like good value for money, and we're not over engineering the tests. Like we don't want to write hundreds of lines of test code.
Yeah.
Yeah.
Like 2 to 1's like roughly the right ratio for this kind of thing.
Yeah.
It's pretty simple code.
Yeah.
The tests do a lot of verification too.
Yeah.
All right, so I guess we should commit this now.
Isaac, just one more check. In our function acquire, okay. There's one assert we could add there if we want to check the bit set a little bit better. We should actually assert. We shouldn't just trust the node index that we get from find first set. We should cross-check it by we do it in release.
Checking is set.
Exactly, yeah.
Yeah, so this doesn't do that assert.
Yeah.
I guess it's not. At node. Does unset do that assert? I think it doesn't. No. Cool. Yeah, these are all pretty much the same.
Yeah. Cool. Like again, it is still, this is like control plane, so it doesn't matter. The more we can do, the better.
Yep. Seems good to me. Let's make sure that passes, I guess. Just for completeness or robustness. I don't know.
Yeah.
It does though. So now we can do that commit, I guess.
Yeah.
Node for LSM implement NodePool. I don't know. What's the prefix for this? NodePool. Kind of related to the LSM stuff, I guess.
Yeah. Maybe we should just keep everything in the LSM namespace, and the point at which we use it outside of LSM, we then move it out.
Yeah. That makes sense.
Then we don't have to think about it further. We just, yeah. Cool.
This doesn't really go in the description, I guess.
No. Everything is fuzz tested and benchmarked. Yeah.
We can just say including fuzz tests in here.
Nice.
Or is that also worthless?
No, that's awesome, Isaac. Yeah, if you want, you should keep that there. And then just above, we can say this will be used for providing the backing static allocation pool for segmented array for the manifest, or something like that.
So this is, or this will be the, this
This
is,
is, yeah,
or this pool will back these segmented arrays of the LSM manifests.
yeah,
How's that?
cool.
And then this could be includes
Yeah,
fuzz tests.
nice. Perfect.
No
DJ's
spelling errors? No spelling
No,
errors.
DJ's been doing like similar testing style to us, also just
Cool.
exhaustively enumerating everything, and he's been doing benchmarks. Yeah,
All right. So that's done now, I guess. So what's next on our to-do list? Um, Did
uh,
that in the segmented array file, I guess.
oh,
Oh, I modified that. Okay, just getting rid of all my scratch buffers. Segmented array.
we can start
We've
to
now,
yeah, we can start to test segmented array now that we've got our NodePool.
yep. So cool. You want to take a quick break first and come back in 5 minutes?
Yeah, good call. Let's do that. Yeah, catch you 5 minutes.
You then.
Cool. Isaac, we back.
Hey, Aaron. Yeah, so shall we get into unit tests for the segmented array then?
Yeah.
Yeah, I think your idea to test this was kind of to have two implementations, like this one here, and then a shim implementation that just uses an array list or something else that's trivial to back it. And then
Yeah.
do the same operations, both implementations, like have random operations we do, and after each operation, check for consistency between them.
Yeah.
That
Yeah.
sound right?
Yeah, that's great. I was just before we get there, I noticed something here where we calculate node capacity. Maybe we want to use div exact.
I'm not sure if we can or not. We can always just like try it and see if it fails. That's probably the safest thing to do.
Exactly, yeah.
And if it fails, then we add a comment explaining why we can't. That
Yeah.
sounds like the right way to do this.
Yeah.
Good call.
Especially because where we remove stuff, we look at like node capacity, or we might just get something funky going on if we've got padding at the end.
Yeah. I think we probably can't because we have, or maybe we can. I think we can. I think you're right that we should just be doing diff exact there. Cool. So all we store here is keys and table infos. And so as long as the node size is a multiple of table info size, it's probably fine. The keys, they're both powers of 2, so it'll work out fine.
Okay, cool. So I think a table info size that might not always be a power of 2. So then it
It
won't
doesn't have
work.
to be necessarily a power of 2, though. It just needs to fit into whatever our node size is exactly.
Yeah.
Elementary const. It depends on the key size, though, so I think it won't work out exactly.
Yeah.
It's 32 plus key size times 2. Actually, is this still right since we added snapshot max?
No, it isn't. Yeah.
Yeah.
So it's going to be 16 plus 24. Yeah, 16 plus 24 is that
Yep.
40.
Yep.
Yeah.
5,
Sometimes
6, 8, yep.
it's easier to program than to do arithmetic.
Oh, yeah.
Yeah.
Indeed. And then you have the 2 keys.
Yeah.
And then those are the 2 keys will either be 16 together or 32 together. Is that right? Yeah.
Yeah. So we're looking at
Or 64 together. They can also be 64 together. So yeah, I think it's unlikely we'll be able to do diff exact here.
Yeah.
And
Shall
so
we
maybe we should
fix
test.
this? Sorry, Isaac, shall we fix that assertion quick?
We just add 40.
40. Yeah.
So we can't do this. Which means we now know that we need to test the case where this
Yeah.
isn't true. It's
Yeah.
probably the right thing to do anyways.
Yeah.
Can't use as we store people.
Of various sizes. Maybe we can say we store table info structs of various sizes.
Or in this data structure.
Yeah.
Struct.
Got it. That's it.
Cool.
Nice.
Now
It's very cool to actually have a comment like that, so that someone will ask, why can't we use div exact? And then they can see we've already thought about it.
yeah.
And yeah.
Yep.
Cool. So you're happy like with that testing style we're just going to randomly insert, remove, and then kind of similar to what we've done, like trying to interleave the inserts and removes. But each time we modify, we check that all the things are one for one the same. Yeah. Cool.
We just start with the text context thing right away then, like a test.
We can even copy what we've just done. I don't know if it
copy all
helps
of
us.
it, or just like a test context, or what?
Yeah.
Oh, we already need the node pool too, right? Yeah.
Yeah.
Yeah. Can I, oh, man. Okay, I'm gonna stop trying to be fancy. No. Damn it. I need to get used to like where all the modifiers are, because they're all on my fingers now, so it's all different than it used to be. There it is. I got it.
Cool. Awesome. No, it's
like
it's
the
worth
simple
it.
stuff
Like
I'm
that.
used to now. Just the more complex things you have to think a bit more, because they're not like in the muscle memory yet.
Yeah. Oh, but
No,
I
I
think
don't
now
want to
we're
paste it here. I want to take it to the other file.
Exactly.
Oh darn it.
It's worth the trial and error, like of reminding, because then you get to a better maxima.
Oh yeah. So here we've got our node size and comp time node alignment. These can just be kind of determined from the from something else probably now. Well, node size I think we have to put in here too. Yeah. Okay. So node size will be part of our
test.
That'll be part of our test thing. Then I think we just use these three parameters though, and then alignment we derive from t.
Yeah.
Just a line of t.
Yeah.
Const node alignment equals a line of t. Could also import the node pool. We can just kind of do that inside the test though. Node pool equals. All right, I was just looking. Got our testing and node pool is kind of in this scope.
Nice.
And then we got the alignment of t. And then, yep.
Cool. Yeah, that's great. Nice intro.
Now we'll still need random. We won't need node count anymore, I don't think. Oh well, we might. We do need that, but I'm not sure if we need it in the struct itself. We can leave it for now. Node map can be gone, and Sentinel can also be gone, I think.
Yeah.
And these will probably need like different names for these, probably. But like
Those
more
will
like
be,
inserts and deletes.
Yeah, inserts and removes. Following what the naming in segmented array. Yeah.
This also line up. Crazy
Yeah.
how English works.
Yeah, exactly. Are we going to need node count here, or do we only need it?
I think we need to calculate it based on the element count max. That's what we need to do.
Okay.
That makes sense?
Yeah, makes sense.
But I think we don't need it passed in here. We just calculate based on that.
Yeah. So it will be element count max. We'll take the node size into account. Oh, but I think segmented array will do that already. It'll work that out for us.
It does,
Node,
yes.
yeah,
Cool. So,
node count max.
yep. And do we ever need any extra nodes? I think we don't. So we've structured this so we never need an extra node.
Yeah.
Well, let's just look at all the NodePool calls real quick to make sure that's true. We've got NodePool. I want so get node. That's if we have no nodes, so that's good.
Yeah.
There's another get node call. So I think we actually like insert when we're full here at this point. Do we have any check to like see that we're? I guess we do have this, but we don't panic if we get full. We should probably have an assertion here that when we do this, this doesn't take us past
Node count max.
past full. Yeah.
Yeah. Yeah.
We just have a assert here. Plus 1 is less than, or just node count maxed. Is that good?
Yeah, it should be node is less than node count max because we're already using less than. So technically
But we're
node
trying to
plus
insert a
one.
new node.
Yeah, so the index of the new node, this isn't actually the check we want to do two checks because we could be inserting a node at anywhere in the segmented array. If we're inserting it at the end of the segmented array, we want to check that the index is less than the max index, which will be it's less than or equal to the max index.
Yeah. Okay, I see what you mean.
The max
We want to
index
assert the
is
node count plus 1. That's what we want, I think.
That's it. Yeah, yeah. But the other one
That's
is
then
also valid.
we're gonna group with that check. And the
Yeah,
other one,
is also
well, that's
valuable.
covered by this check now because we assert the nodes arrays less than node count. And we know
Okay,
that
good.
node count plus 1 is less than node count max, and so
Yeah,
by the transitive property we do cover that as well.
yeah, that's
Cool.
great. We just got it off by one because the node count must be less than or equal to, because they're the same unit. Because count
Oh
max
yeah,
is
you're right.
inclusive. Yeah,
I think I want to
that's
use
it.
less than or equal to here though, because this makes it very explicit. We're thinking that we need at least one free slot.
Yeah.
Do you agree with that? Or is
What
this like too weird?
what do you want to do, Isaac?
Like there's our two options are this, which
Yeah,
is
that's better.
fine.
Yeah.
Okay. So we do want to ensure that we've got a free slot, but I think that's fine. I'm just overthinking this.
No,
Cool.
that's better. That's a safer way of writing it because you can
Yeah.
see what we're just saying is that let's just check that we're not already at max. We're before max, so that's fine.
Yeah. Let's go find the next pool here. Remove. That's the only place we actually get a new nodes. There's just when it's 0, we already checked that case, and in that case there.
Yeah.
Then for removal, we already have an assert that node count is greater than 0, so I think we're fine there.
Yeah.
Compact. Oh, we can get rid of compact. That is just dead code.
Mm.
Okay, so node count is going to be, well, we need to kind of like create our type then for our test array. And apparently this now needs to be generic over the node pool as well. Maybe instead of passing in node size here, we just need to pass in the node pool type and then get the node size from that.
Yeah, that makes a lot of sense.
type, and then node size. Should have here just a constant node size, I think.
Awesome. And you know what's so great about that is that remember we had that concern right in the beginning that we've got two U32s next to each other, you can mix them up,
Yeah.
node size, and now that's gone because we're passing in it.
Indeed, yeah. Well, you can switch these two types, but that seems like it's harder to do.
Yeah. Then it wouldn't duck type.
You definitely get compiler in this case.
Yeah. Yeah. But
So this needs to expose the node size as a constant then. Pub const node size equals node size. Darn, that's shadows now. Do we just call it size in the argument then, just so we can get around the shadowing?
yeah.
But it's not. It's annoying. Not the size of the node pool itself; it's the size of each node.
Yeah.
I think there should be a shadowing rule where if the names that are shadowing each other refer to exactly the same value, and that can never change. Like it's the same comp time known value, then you should be allowed to shadow.
Yeah.
That might be
Yeah.
making things too complex, though.
Yeah. It's a cool idea.
I say we should just stick an underscore in here or something like this.
Yeah.
Like do underscore node size.
Yeah. Yeah, that's cool.
I don't see a better way to do this, unfortunately. It's just kind of awkward. You can move these asserts down, perhaps, and then use this node size. So you don't have to use the underscore very often.
Yeah. Can we do the underscore at the end?
We can do it at the end, yeah.
Or then
All
it
right,
sticks out more because we've got the colon there, right?
Yeah, that
Maybe
makes
it's
sense.
nicer leading.
And the semicolon here.
Yeah.
I think alignment we don't really need to expose. That's part of this node type. Oh, you know what? It's already part of this node type, so maybe we don't need to.
Yeah.
It's just like node.length. Oh, let's choose that instead, maybe.
Yeah.
And also can't get out of sync.
Yeah.
Here we
Yeah.
have node size, just node.length. That seems all right.
Nice. Yeah. That's very nice. That's much better. Good catch there.
Thanks. Pass in the node pool and the element count max. This is fine. So in the test, we don't actually have to do it in that order. We can still define the node pool based on the element count max. We get passed in here since we have our different comp time parameters here. Okay, so node count is now going to be. We still need to finish this. So test array. So segmented array. T node or test pool. And then element count max. And then here we'll do node count equals, this will just be test array dot max node count max. Cool. Did we make that public? I don't know if we did. We did. Yes. Nice.
Nice.
It's coming together slowly.
Yeah. We've actually done a lot, like segmented array, NodePool, manifest level, using all of that. Yeah.
Yeah, the manifest is a pretty big undertaking. I've realized at this point.
Yeah.
I think we both realized.
Yeah. Yeah.
That's cool. So here we are. NodePool, look at that. Yep. Inserts and removes. We got our test pool now, initialized from the allocator. Then we've got, we don't need this hash map anymore. We instead need to initialize the segmented array.
Yeah.
I'm not sure we even wrote an init function for that yet, to be honest.
For the segmented array.
Sentinel stuff is gone. Yeah, did we write an init for this?
I don't
No.
think we did. No.
Guess we need to do that now.
Yeah.
These things all just get initialized to zeros, I guess. You know, this can be like statically initialized actually.
Yeah.
This one can be all nulls. This can be, it'll be, yeah. It's gonna be slightly awkward to type out, but I think it might be fine like this. It'll be, oh, it's a pointer though, so it has to be, okay, never mind.
Yeah.
We got allocate them here. These are all pointers. I thought they were just arrays and lines. I was gonna like statically initialize them, but you can't do that because you can't like allocate in that scope.
Yeah.
So let's allocate the nodes. Const nodes equals pager dot alloc type in n. This is gonna be node capacity.
Oh, it's going to be node count max. Oh, yeah, it's node capacity T.
T, and
The
then
node count
count is node count max.
max. Yeah.
Yep. It's gonna be try, of course, and then we're gonna have an error defer.
Allocated.free.
Free nodes.
Counts.
Allocator.alloc. U32.
Node count max.
Error defer.
Indexes. I was thinking this morning how indexes is a nice name because you pass in a node and it gives you the index of that node.
Indeed.
And from there
it fits the rest of our naming really well too, because that's the same thing style we use for these two.
Yeah.
We still want to get rid of this at some point, maybe. But I'm really not sure it's worth it until we finish. It's just going to make things a little bit more complex. And so I want tests done first, for sure.
Yeah.
Free indexes. Okay, so we've got those things now. Now we need to initialize them. Mem.set. Oh, it's gonna be annoying. It's gonna be as. Oh no, it won't. It'll just be this. Never mind. That's not any type. It's still kind of annoying, but it's okay. Nodes null. And the other ones are just zeros, so.
Yeah.
Counts 0. That's the initialization we need to do. I think that's everything too. We only have these 4 fields.
Yeah.
Cool. And nodes.
So it's nodes, counts, and indexes.
And then node count just gets set to 0. I think that's it. The dnet, we just need to free those 3 things, then we're good. So now let's see if I can get this keybind right. Yeah, got it. This needs to be, we're taking the array. This actually doesn't need to be mutable. It's just like that.
And then I was thinking
All
what
right.
we should assert here as well is that node count is 0.
On DNet?
Or, yeah, because otherwise what could happen is we could de-init it, and yet the nodes have still allocated from the node
NodePool.
pool. And then you've
Or
got like a leak.
should we remove all the nodes from this here? We probably should.
Yeah, then we just remove everything. That's the other way here.
Yeah.
So we just loop over the nodes, calling
Just remove
node pool
yeah.
release. Yeah.
Indeed. I'm trying to think of like when we'd actually de-init this in our actual code, as opposed from our testing code.
Yeah.
I don't think we don't ever actually de-init this in our real code, at least currently.
No.
This would be alive until forever, essentially.
Yeah. With the Whopper, like we want to shut down nodes and free everything that they've got.
Right, we want to do the crash simulation. That's why I ended up adding dinit for the replica as well, is to simulate crashes.
Yeah.
We do want to do that dinit properly here. So I think we simulate crashing though. So I don't think we don't want to have to add code that then loops over the thing and frees it elsewhere. So I think we just want to free all the things here. So for array.nodes 0.array.node count node node pool. We need to pass in the node pool here then, I guess. Yeah, that makes sense. That also is good because then it indicates to the caller that the node pool is needed.
But I think we do have access. Okay, yeah, cool. Yeah,
no, we don't. We just pass it in on insert and remove, which I think is better.
Yeah.
Really reason to store the pointer here. Kind of the same thing with the allocators, where we take the more explicit route of using like an unmanaged API and always pass in when it's required, instead of storing a pointer long term. Like then you don't need the node pool to iterate, which makes it clear that iteration doesn't like allocate anything.
Allocate, yeah. No, 100% agreed. I really like the.
I also think it'll make the dinit code easier to write correctly because now we've got an ordering thing where you've got to dinit this before you dinit the node pool. And that's then very clear in the instruction signature too now.
Yeah. Awesome. That's really, really good. So much better.
Node pool.release. Node
and this is
question mark. Oh.
I don't know.
Well, you know what? We need to do some pointer casting here, don't we?
Yeah.
So there's one other thing here where our node type is not the same as the node pool's node type, because we're using T here to avoid pointer casting everywhere in this code. We need to now cast this to the node type. So it's gonna be like mem.bytes.
Okay.
As whatever. Where'd it go?
Bytes as value.
Or like pointer cast. I think just doing a pointer cast would actually be fine. We won't need the align cast because the alignments already should be right.
But
so
shouldn't we rather just use mem.bytes as value because it will do all of it for us?
As value, I was just gonna do I'm gonna write what I was gonna write, and we can compare them.
Okay.
I'm gonna write pointer cast node pool dot node. Oops.
I wanted to ask your advice for this also on DJ's EWA PR. I think I pinged you there. There was one section where I was wondering if we were doing the cost correctly for the marker. Do you remember that? Like yesterday or the day before?
I don't think I saw that. I should go look at that.
Okay, cool. It's on his PR. He's landed it already, but you can just to double check that we're doing the right thing there.
Sure. Yeah. I'll go look through the pings there.
Yeah.
Yeah. I get way too many GitHub notifications, to be honest.
Yeah, I can understand that. Because you're watching the whole Zig repo, right? Uh,
I watch too many things. Like
yeah, you
it's
watch all the
now
repos. Yeah. Cool.
um node. Okay, this will just cast it to this type, which the node pool uses.
Yeah.
Whoops. Node pool, which is this right here. We should probably move this like up towards the top, maybe. I feel like it should go
Yeah.
here.
Yeah.
I don't know. And we also
Definitely,
need to
because
get rid of
it's
the comments now gone.
yeah.
Guess we should have done that in the node pool command. We can actually fix that up right now if you like,
Mm,
before we push it remotely.
yeah.
Um, just to make our commit a little slightly cleaner.
Yeah.
Just
Nice.
fix up. Oops, there needs to be a dash, and then or that should be a dash dash amend. Whoops. And yeah, I can erase dash I head tilde 2. Okay, now it's all better.
Cool.
And so the other option here, I guess, would be one of the std.mem functions, but none of them take a pointer. That's kind of awkward. Like they all want to give you a pointer to a value, and so they won't like do the alignment properly. I don't think. I could
Yeah.
be wrong.
I think bytes mem.bytes as value will do the alignment.
Okay, but it's as value, so I think it takes a value type, not a pointer type. And so we'd have to like pass the child type of node, I think. Um,
So it says given a pointer to an array of bytes returns a pointer to a value of the specified type backed by those bytes preserving pointer attributes.
yeah, but the problem
Is
is we have to pass in here then. So I'll type this out just a second.
okay.
Mem.bytes as value, and I can jump to the definition. The problem is this won't compile because this t that it expects is not a pointer type; it's a value type. And so it's gonna, I'm pretty sure. So it does like
Okay.
size of t. And so here, what we would
Okay.
have to do to use this would be to pass, not that, but instead, like a
Okay.
node size U8 array.
Yeah. Cool. No, thanks. Now I understand.
And I think this pointer cast already gives us all the safety checks we care about. Well, it doesn't check the length. That's the only issue.
Yeah.
I think bytes as value will check the length for us. There's not one here that checks the length, though, I don't think. We have 2 bytes. No, that's value based. Bytes 2 value is also value based. So it could be slice as
But
bytes could maybe give it to us, but that won't give us
yeah.
that won't give us a pointer to array.
Yeah. A
Slice
bitcast.
as
A bitcast doesn't work on pointers though,
oh,
right?
this might actually oh No, bitcast won't help us with bounds checks here. It's the same. Bitcast is pretty much defined as bitcast is equal to like just pointer cast t or and foo dot star essentially. That's like
Yeah.
bitcast star.
Yeah.
So these are
Exactly.
equivalent essentially.
But
Um,
bitcast will also check that what you're casting has got the same size. And I think
right.
bitcast yeah. What
So
we
we
could
could
do is,
do bitcast then. Well, but then it gives you a temporary there. It won't give you the same memory necessarily.
yeah, yeah.
Um,
What if we do like a compile time assert that the sizes of the two types are the same?
I think that's what we need to do here. And
I'm
this the
using
sizes of the
type
children
of.
though actually.
Yeah.
We want to assert comp time assert method. We get meta in here. Bit lm and actually it's not the elm, it's the child I think for the pointer to array. Yeah, now it's child. That child node pool dot node or type of that is already typed. Okay, so that's good. We want to assert the size of this is equal to type of node, the child of this. Yeah, so size of the child type of node.
Nice. Yeah.
And then we also go quickly look at what meta.child does to make sure it's the one I want. Yes, it is. And so it'll just give us the child of the pointer directly. And so
Okay.
this will then give us the array type. So that this expression here will be, where's NodePool? Will give us this type here, node size U8.
Yeah. Okay.
And this expression here, meta.child type of node, will give us node capacity T.
Okay. Does it ignore? So it ignores the optional.
So we actually can't do this assert there because we've got padding though.
Yeah.
Because we
Yeah.
don't do
Because
diff
of the
exact
optional.
here. No, it's not the optional. The optional is free. That'd just be
Okay.
a null pointer. We can't do it because
Okay.
we don't do diff exact here. We can't do this assert.
Yeah.
We don't. This pointer doesn't actually cover the padding bytes at the end we might possibly need.
Okay. Okay. Wow. That's pretty
Which is
interesting.
fine.
Yeah. Yeah.
But we just can't do this assert here.
Yeah.
We just have to. Pointer cast is the right way to do this then.
Yeah.
Why am I scrolling?
Cool. It's nice that we fleshing out the space, the
Yeah.
negative space.
Yep. So I'm confident in that now, though. And that's not
Yeah.
bad. We still get safety checks for the alignment, and yeah. Well,
Yeah.
we don't even need to cast the alignment because the type alignment's already correct.
Yeah. Oh yeah, I think this is a
Cool.
good place to hang 10 for the day. What do you think?
Sounds good to me. Yeah, we just got dnit and init done. We didn't start the testing yet, but we're ready to get rolling on that tomorrow.
Yeah. Awesome.
Yeah,
Got a bit of scaffolding for it and got the
for sure. And
yeah.
we're in test mode now because we just did the test for the node pool.
Yeah, definitely. Awesome work, Isaac. I'll send us
Thank
off.
you. You too. Go
Thanks.
ahead.
Yeah, Tiger Beetle sessions, January 26th, session 11. See you tomorrow. Same time, same place, same space.
See you then.
Ciao.